Okay, this is a little addendum, but I'm putting it at the beginning, or I got to figure out how to put it at the beginning because this is important. When you're using packages, first thing you should install is revise.jl. Okay, so just go search that, go add revise. And we'll see later as I'm using a package and I make modifications, all my changes are just available. So in brief, what it does, all the packages that I have in my environment, if anything gets changed, the functions get changed, how things work gets changed, all of that gets automatically reloaded, recompiled, and is just available to me as I'm using those methods and types and things. Well, types is sometimes if you change types, actually you're gonna have to quit and restart, but revise can handle everything else. This is like essential functionality, should be built in, but you can make it automatically load as it says here. So you can just put it in the startup file. So if we look at mine, Julia config startup, that's literally all I have in my startup file. You could put other things you want Julia to do every time it starts up. But all I have is using revise because I mean, it's kind of essential. I don't even know, I can't even remember what you do if you don't have this. Like if you make a change, probably have to reload the package or something, or anyway, just add it, make your life way easier. Okay, now I've got to figure out how to splice this back into the main video. Today we're going to talk about packages in Julia, starting with some basics. We'll move on to some more advanced things later, from everything from kind of using packages to developing your own. First, briefly, just on the package manager, you should look at the docs. I'll just cover a very few commands real quick, but documentation is good. You're going to want to add packages before too long. So let's say, for example, I wanted to use the forward diff package. This is one that allows me to do forward mode, logarithmic differentiation. So if you find a package that you want, you have to see, is it in the general registry or not? All these main packages will be. If not, we can still add them, but I'll show you that in a second. So let me just open up Julia here. We get into package mode. I don't know if I talked about this before, but there are a few different. This is the regular REPL mode, right, where I'm just setting variables. But if I want to go into package mode, I hit the right square bracket, right? That gets me into package mode, and then the backspace gets me out. I could do semicolon, that gets me into shell mode. So I could, for example, just use, I have nothing in this directory. Just use regular shell commands, for example, backspace out. So let me go back into the package mode here. I could add a package, add forward diff. Turns out I've already got it on here, so this is not going to do anything. So it says no changes. I could, let me add a package I don't have on here. Let's say finite diff. That might be more interesting. So it's going to go find it in the general registry, and it added it. And so now if I go, ST gives me my status. I can see packages that I've added. There it is. There's the one I don't want. So I don't want it anymore. So I'm going to remove it. I'm just going to get rid of it. And I look at the status, it's gone. I can also do what's called dev or develop a package. These are ones that I'm going to be actively working on. We'll see that again later. So an add a package is something that I don't plan to change it. I just want that functionality, put it in. Dev is one that I'm actively working on. So I can also add things by path. So let's say forward diff was not in the registry. I could go here to this get URL here, and I could add it that way. I could say add, and I give it the URL. Or I could clone that package, go into the directory and say add dot. All I need to be able to add a package is it has to have what's called a project toml, this thing right here, this project.toml file that in the right format. And that's what lets Julia know this is a package. But these ones that I can just add by name, they're in a general registry, which we'll see again later. So let's see, what else do we want to do? You can update packages, right? And you can update package and its dependencies running that specific package. We can run unit tests, which we'll see later. So let's say I wanted to run the tests here for forward diff, for example. I could run those unit tests. I'm not really going to cover this too much. Take a look at the docs though. Environments are also a useful thing. Notice here I'm in my general environment. This is just for my Julia 1.9 version. We'll see examples of this later, so I won't worry about that too much for now. what I want to do is show you how to create a package. So let's say, for example, let's just create this temporary file here. Let's say you've been doing scripting like we've been showing in some previous introductory videos, and you've just created a few functions. This is some function here that takes an x and y, and it's just going to do x times y, and then it's going to return z. I mean, I'm just doing some silly things here. And then we'll have another function that takes in x, y, and z, and returns some of those things. I don't know. These are kind of useless functions here. And then I'm just going to create a couple variables here, and I'm just prototyping here and seeing what happens. And then obviously this is really useless, but just wanted to get something going. Okay, I just added and removed some packages, so it's actually going to pre-compile for a second. This won't happen this first time. Yeah, I can't do that because those are just floats, so whatever. Okay, so there's some functionality, and scripting like this is fine. This is great for prototyping, but eventually I'm going to want to reuse some of this functionality. So let's say I've got also some types here. Let's make a type. This is my type here, and it's just going to have some floats, x and y. That's my type. And so let's just change this function here that it takes p, which is of that type. And let's do that just for fun. And this is going to take in t and z, let's say. Obviously, this is like totally dumb code, but anyway. Okay, here we go. Change that to t and this to a t. Yeah, great. Okay, so now I've got some code. It's got a bunch of types and functions, and I've been prototyping here, and I don't want to stay here forever, right? Because first of all, these are all in the global space, so that's not great. But also I want to be able to reuse this functionality, right? These functions are going to be useful elsewhere, and I want to put this in a package. So let's generate a package. The way I'd recommend you to do it is to use a package called PkgTemplates. So we'd go here, and we can do this here in this REPL. We can go and add package templates. Actually, I already have it, so this is, again, not going to do anything. But if you didn't have it, you go here and add package templates, and then you should go look at the docs. It's worth reading through. It's pretty straightforward if you go look at the user guide and just see what it does for you. It's got some default things it's going to do for you. And they're all going to do the kind of minimal thing that you would do anyway if you're going to use any of these things. Like, it's going to do kind of the bare bones stuff, but it has some optional things here. And it gets updated over time. So, you know, what I'm going to do is I'm actually going to use, well, it was right here, this interactive code. But if you go here just on the homepage here, it gives you this example to say, hey, let's use interactive true and give it the name of your package. I don't even know what directory I'm in here. I'm in, okay, so let's just go to I just created a temp directory. So here I'm in my temp directory. Nothing in here so far. I'm just going to use this temporarily, and I want to make a package. So I'm going to say, let's use package templates, and now I have, I got this function called template interactive equals true, and now I'm going to give it the name of my package. So let's call this one cool package. Yeah, and then we're just going to run this. So it's saying, what things do you want to customize? If I don't want to customize anything, it's just going to do default everything. I'm going to say for now, let's customize everything. So I just say A all, and then I'm going to say D for done. Okay, enter the value for the user. That's going to be your GitHub user, or if you're using some other system like GitLab, it'll be your user. I'm going to put in, we have a team, so I'm just going to put that in BYU Flow Lab, but you put whatever, your personal user or your group user. You can change that later, but I'm going to put that. You can put your authors. It's pulling a default for me here, which I'm going to use. By the way, these are coming if you've used Git. You've probably set these already, like a a default user email and GitHub user. If not, you can do this git config global to do this for you, but it's just pulling from that. So yeah, I'm going to accept that. That's fine. My directory, I'm going to use the current directory. So I'm going to use dot. I've already cd'd into my temp directory. By default, Julia stores these packages that you're developing in this .julia.dev folder. I like to store them where I want to store them, so I never put them there. I have like some repos for papers, some for like code type things, and I want to organize them how I want to do it. So I always just kind of put it in the dot. Here's where I'm at right now. What's my hosting service? I use github.com. You might use something else, but choose that. Minimum Julia version, you could choose there. So that's going to depend on kind of the features you're using. So let's say I want to use tuple unpacking, and I think that requires at least 1.7. So I'm going to select that. And then it's going to say, these are all the things I can do for you to kind of set up the bare bones templates for those. And all the X's are the ones that does by default. Those are all good. The other ones that, well, the one that I always do, unless you've got a really simple package that's only just gonna have a README, I would add documenter. So I'm gonna add enter for that to select that. So that's gonna be to add documentation. If you're using different systems, right, instead of GitHub, maybe you want GitLab CI or whatever. The other one I'm gonna add here is a dependabot. I'll mention what these things are later. Okay, so let's just select those, D for done. And by the way, you don't have to do this interactively. Like you can just, an example here, right? But I find that these things change a bit. So, and I don't do this, create packages every day. So compat helper. So all this other stuff, I'm not going to customize. All the defaults are pretty good. If I want to go change them later, I can, but I'm just going to say done, not customizing any of this stuff. The only one I'm actually going to customize a little bit here slightly is the documenter one. So I'm going to wait till that comes around. Documenter. So the deploy style, I want it to use GitHub. So I'm going to select that. And yeah, no more customization. So that's it. And now it's just going to run and do some stuff. Okay, there it is. So let me jump into my shell mode here and do an ls. And so I can see the folder. It's called cool package. That's the name that I gave it. So if I go into there, you can see it's created a bunch of files for me. And actually, I'm going to just jump over to terminal, even though it's the same thing. Just gives me a little better coloring. Okay, so there's my terminal. It's created some files for me, some folders. It created a license for me, which by default was MIT. If I didn't want that, I could delete it and put a new one, or you could change it as some other default options. It just created a README, which is going to be extremely basic, right? Just all it has is just some links, and we'll talk about what these are later. These are for documentation. This one is for automated testing, but you could delete all those. I mean, there's really nothing here. You create a project. TOML file, which I briefly mentioned is what you need to have a project. Actually, let's just take a look at it, but we'll talk about it more later. So here's what it looks like. This is kind of the format. Most of these things you won't need to edit. A few things you might. So if you want to change the name of your package, you could. You just got to change it in a few places. We'll have to change it in the test and in my README, but yeah, we could change that. Probably will change the authors, right? Like maybe someone else starts contributing, right? Other person is here and so on. You might change that. Don't mess with these UUIDs. They're auto-generated. The version number you might want to change, right? This is an appropriate one for starting out, or maybe you're doing a 0.1 if you're not ready for that. But you can go look at the semantic versioning. But in brief, this is the major version, minor version, and these are like the I don't remember what the word is, but very incremental changes, right? So the meaning here is that if you change this first number, that's a major change, meaning a breaking change. So, for example, if I went from 1.4.2 and if I all of a sudden went to 2.0, that's a breaking change, right? I can't. There's not backwards compatibility. But if I went from 1.4.2 4.3, that's a very minor change. 5 would mean there's a feature change. Features were maybe added or so on, but it should still be backwards compatible. So if you have a leading 0, by default, these are all like once you change this number here, since that's the leading number, that's going to be a breaking change. So that's partly why a lot of the packages have encouraged, once you get to something at least reasonably somewhat stable to go to 1.0, you have another number here to work with at least. But anyway, that's the version. You can change that, set that as appropriate. Compat, again, we'll talk about this later, but this tells you, this is what I selected before. Remember, I said I want Julia to have a minimum of 1.7. Actually, let me see if I can go find that here. So if I go to the compatibility section here, this is worth a read, right? It'll tell you what some of these things mean. I don't often use many of these ranges things, but you can use ranges or commas and so on. Typically, what I would use at least is kind of a minimum, and you can see there's different options here. But so if I say 1.7, that's a minimum, meaning it's going to be good for 1.8, 1.9, 1.10, 1.11, 1.12. But if somebody wanted to use 2.0, which doesn't exist right now, right, like that wouldn't work. And you couldn't use 1.6, for example, it's just saying you got to use at least 1.7. And in general, we need to specify these for all of the packages that this package depends on as well. We'll talk about it later. Other stuff here you don't need to change. So that's really it for the project file. It's pretty simple, but let's actually modify it. So let me go back to my terminal here. So I'm in my package, and I'm going to open up Julia, and I'm going to actually no, let's change my code here. So it's actually more interesting. Let's say I'm going to use, I should have really thought about a good example before we'll use something that's built in. I don't even really have to add this, but it's actually, I'm not sure if this is going to do what I think it will, but we use the mean from statistics. Okay, so let's see if this does what I think should happen. I know where there's kind of this transition where all the base packages are going to move out and have separate version numbers. This might look slightly different because we're not there yet, but we'll try. Let's see what happens. So I'm going into package mode. I'm in 1.9. That has all these packages, but what I want to do is I want to activate my current package, the one I'm at. So I'm going to put activate dot because I want to go to the directory I'm in. So notice how this prompt here changed to say cool package. I'm in my cool package, and when I do status, there's nothing. I have no dependencies here. I don't have any packages. So I'm going to add statistics, although, okay, so it did that. And notice it changed my project toma automatically. It said, okay, here's a dependency, here's statistics. And in general, so all the things that I need here that are in using, like let's say I needed forward diff and I needed, whatever packages you wanted to use, I would need to add them to my dependencies, right? Because my package depends on this package. And then what I should do here is that I should then add a compat for that. So I'm on 1.9. So let's say I've tested it now. I know it works on at least 1.9. I would put 1.9 here to say, okay, I want, and maybe I could relax that. Maybe I go back and test. I know, well, this actually works on 1.8 as well and 1.9, whatever it is. But I'm actually just going to say, let's keep this current for now. 1.9. Okay. So that is that. So let me get out of here. Go back to this. All right. So what else did it create for me? Like I said, license, just MIT license, README, bare bones stuff. Manifest, we'll talk about that later. Source, I mean, it was like nothing. It just created just one file here and it does nothing. It just has this module keyword, which is key to have a package. So what I'm going to do here actually is I'm just going to copy this stuff out. Well, actually, sort of. Let me first talk about this. So you can configure this however you want. And if I really had a package that was as teeny as this, I would not break it out. But normally you're going to have multiple files. So let's say I've got my module called cool package. Here's a typical kind of structure. Typically, people will have kind of all their imports here. They're going to say, these are all the things that I depend on. So in our case, that's just statistics. And then there might be more, right? I mean, maybe it would depend on for diff and maybe it depend on other things, but whatever, you put them all here. And then I would put my includes, and this is just going to mean I'm going to take some files that are in my package. So I haven't created these files yet, but let's say I've got one that's kind of like a preprocessor type of thing. And I've got one that's like my utilities. And I've got a file that's like I don't know, algorithms. I'm just making up names here. They're not maybe super useful. So these are just different files. Okay. So let's say include, all it does, you could think of it, it's literally just like copying and pasting whatever's in that file and putting it here. This is just a way to organize so that, you know, as your files get longer and longer, you don't have to put your entire package just in one huge file. So let me do this. Let me just break this thing up here into these really tiny things. So let's say I had a file that was called my types. This may or may not be the best organization for you. This is just an example. I'm going to create it, put that in there, and then maybe I've got an example. This is like so overkill. So I'm just going to put both of these two together because that's going to be it. This is going to be my silly thing with just two things and with these great names, and that's it. So I've got types and functions, and I just included them here. Again, this is just a way to kind of organize things a little better as my files get longer. And then we usually have exports. This is kind of a minimal thing here. And this would be, I don't have to export anything, but these would be like, say I wanted, let's say another was a function that I wanted you to use, and so I might export another, and maybe I'll export both of them, some and another. What does that mean? Well, so when I enter, let's say I go into Julia and I say using cool package, what's going to happen? And actually, why don't we just go ahead and do that? Oh yeah, I haven't actually added this. So before I do that, let's go back. Two things I want to say here. One is, okay, I've made this package, but it's not really available to me anywhere in Julia. So here I'm on my 1.9 and I hit my status. It doesn't know about cool package. That's not even on there. So we're going to add it. And I'm obviously working on this. So instead of adding it, we're going to dev it. So I'm going to jump into my REPL mode here. And I'm going to say dev my thing right here, okay, which is cool package. So now it's added it. And if I go back over here, I can see, oh yeah, it knows about cool package. So if I go in here and I say use cool package, like, oh, cool, I know what that is. And it's conflicted because I was actually already running some things with cool package. So I'm just going to restart here. Because I had, anyway, let's say, oh yeah, again, let's say using cool package. Okay, so now I've got it. And now, for example, I can autocomplete and it says, oh yeah, there's this function sum and it's in cool package. And I never put a doc string, so it's not telling me anything useful, but that's a topic for another day. But these functions are available. Actually, any function is available to me. So the difference is if I put something in export, now I could just do something. Well, actually, I really should export the type as well. Let's export my type because that wasn't exported. Well, I didn't export it, so I'm just not going to do it. So let's say, here's the difference. If I don't export it, I have to fully qualify the name. I can say cool package.mytype, and then I can do this, right? But what I can't do is I can't just say my type because I did not export it. It's going to say, I don't know what that is, right? That's not defined. So whereas what I can do, I did export sum, so I can just say sum of t, right? I can pass in that type and that just works because I exported it. So what do you put in export? Really, that's a design choice. Typically, it would be things that are like the public API, right? These are the things that I expect you to use. Things that I don't export are internal functions that you could use, but you probably won't. And so if you really want to use them, you got to fully qualify it. That's a typical design choice. Another choice is to not export anything because what's going to happen, right, is when I put using, it's going to dump all of these things into my namespace. And especially if you're using some names that are going to be very common and are probably going to conflict with other packages, then I don't want to put them in my namespace. I'm going to say, I want you to fully qualify. So for example, I give you for diff example. They're not going to dump in Jacobian because that's going to conflict with others. And I want to be able to use the for diff Jacobian as well as the reverse diff Jacobian, right? So I'm going to fully qualify those. So again, just a design choice. Anyway, that's typical package structure. Again, this was like ridiculously simple, but that's kind of what that looks like. So let's see, let's go back here again. Test, okay, so what's in test? Test right now, I'll just have this one file. It's called run test, but typically it's going to have the same kind of thing where it's going to have a bunch of includes because I'm going to have many tests. But for now, let's just say I have not very many tests. Here's where I run unit tests. And if you don't know what unit testing is, you should definitely read up about it. But let's see. Let's pull up syntax for Julia. Basically, if I want to run a unit test, I just give it this test macro here. So here's where I would write tests. Like, for example, I would do S, or yeah, let's say T equals my type. I guess I didn't export that, so I'm going to have to do this. 1 and 2, and I don't remember what the heck it's supposed to be. Let's see. When I do some of it, it was some weird thing with the cosine. So I'm actually just going to cheat and copy this. So when I call sum, which is really confusing because it's not a sum like as in adding, it's just some dumb name, get W, and then I want to assert, I want to test that W should be, I'm going to use is approx. W should be approximately this, okay? Let's just see if that works here. So I'm just going to run this line by line first. Okay, great, test passed. And let's say, I'm comparing some data, so I really don't know that many digits. Let's say it's about that. This is going to say, oh, there's a problem. There's flags here, right? Keyword arguments, absolute tolerances, relative tolerances. So I use isapprox a lot more than I use things like equals because I'm usually comparing floating points and I'm comparing to like experimental data or verification data that's maybe to 1 to the minus 14 or so or something. So anyway, I use isapprox a lot, and the keywords A tolerance for absolute and R tolerance, you can go look up exactly how those are used. But this is very useful. So I would write all sorts of tests here, right? These are very important that you write unit tests, but I would add more of them here. And so just give you an example. Let me just pull up one of our codes. So this is GXBeam. So first, let's say we looked at the source. I looked at GXBeam. You can see it has that kind of structure, although it's much bigger, right? It's got using, exported things, we included things. And so it's pretty, it's sometimes useful for someone to go look at this because then they can kind of see what are your dependencies, for example, and kind of what are the files. It kind of gives you an overall layout instead of trying to dump everything in there. And then if I go into tests, we'll see the same kind of thing here. In our tests here, run test is the kind of name of the thing that gets run first. Notice it's just including a whole bunch of other unit tests. So if we go into one of them, this is the one I wrote here in section. So section is another file. It just has its own different tests. And you can break them up into these test sets, like was done here, or you don't have to. But test sets just will kind of group them into logical things, like say, oh, these are tests about my stiffness matrix. These are tests about section properties, and there's a bunch of them, and these are tests about a different geometry, cylinder, so on, right? And you can see each one might have a whole bunch of different tests. Again, just ways to logically group them, or we're going to test a whole bunch of things right here that they're all equal. So you want to have these kind of unit tests. So let's go back here. Yeah, so let's see, we covered testing, source, project. Let's talk about the manifest real quick. So difference, when would I use the map? So actually, let me say this. When I commit this project, if it's a project that I want other people to use, and maybe it's not publicly available, maybe it's just on my private GitHub or somewhere, or it's just on my local computer project. Many of my projects just exist locally. They're just here for me, right? So if I, again, open up Julia and go to package manager, actually this one is totally on these ones are all on the web, but I'm editing them right now. So I've cloned them and I'm editing local versions, so they're dev'd. But this one that we just made, cool package, that doesn't exist anywhere, right? And that's totally fine. I'm still working on it, and maybe later I'll be ready to make that public and register it. But when I commit a project, there are multiple things, I don't know what to call them, code groups. I'll just talk about two. One is a project. Project is something that's going to be reused, right? And so a project doesn't specify the exact version. It specifies kind of minimum or maximum versions, right? It kind of specifies compatibility. So I don't care if you have exactly 1.9, I just need statistics, and it needs to have at least some certain version because I'm using some function that only exists in that version, for example, or in at least that version. I don't want to specify exactly things, because this is meant for reuse in a larger project, and someone is going to use my cool package to do all sorts of different things. Whereas the manifest I never directly edit. It lists everything, like not just those dependencies, but all of their dependencies and all of their versions, all the UUIDs for everything. So it's got these unique identifiers for everything. This is going to be able to specify exact versions of things. So what's the difference? So if I'm creating a project, I don't commit my manifest. That's just going to live here locally, and I would never commit that to my repo. So if actually it created a git ignore for me by default, and you can see that it put in the manifest into my git ignore. Meaning I shouldn't commit that generally because I don't want other people to be required to use that very exact version, but rather some compatibility range, right? Like that exact version doesn't matter. A different use case would be, this is not a reusable project, but this is like a one set of scripts that does a very specific thing. And then I want to commit the manifest because I'm doing it for reproducibility. So an example would be, let's see, I think I pulled this up the other day. No, that's not it. Let's see, search public here. This one. Okay, so here's, for example, a repository I put out to reproduce some results in one of my papers. And here I've committed the manifest. This is not a project. This is not like functionality to reuse and so on. This is, and this is a good thing to do when you finish your paper, right? That even if it's, whether or not you make this public or not, this one is public. You want to be able to reproduce all your results, and you will probably have to go back to that, 6 months later, and you get all these reviews, and maybe you need to go change some things, and you've been changing versions, and you're like, oh, I can't reproduce my thing. This is what you do, right, at the time that you submit your paper. And also it's a good thing to do when you publish, right, so other people can reproduce results. Get your scripts that generate all those things, commit them, and then you push your manifest. And again, your manifest is this exact thing of the of all the versions of all the things that you've got. And then so somebody is going to come into this project, they're going to activate it. So let me go back to the package documentation here. You go to activate, and then you instantiate. So it talks about this somewhere here, using someone else's project, right? So activate it, and then you just type the keyword instantiate, and it's going to download those exact versions. So this is for reproducibility, right? So different purposes here. One last thing I want to say here, well, on the kind of beginner's part, is on the unit tests. Let's go in here. I might have test-specific dependencies. So for example, I often in my unit test will want to test the derivatives. And so maybe I'm going to need forward diff or reverse diff or things like that in my unit test, but they're not actually needed necessarily in my main package. So I don't want to add them as a regular dependency, but I want to add them as a dependency here. So I'm going to be in this test folder. I'm going to activate this current directory. And so notice it's now test. And I'm going to say, for example, add forward diff. And it's going to do the right thing. So if I back out of here and I look at that project TOML, and actually let me just open it so it's very clear. Notice it doesn't have all the other stuff that this package has. It notices that it's a test thing. And so all it's saying is, oh, you have a dependency on forward diff. And that's all it's doing, is saying, oh, you want to add additional dependencies that are only specific to when you're running unit tests. And yeah, as we mentioned, we could run unit tests. I can now run my cool package unit test, and hopefully I did this right. Oh boy. Oh, actually, shoot, did I not get rid of my forward diff? I left forward diff in there, so it thinks I need it. So it's going to get that. Oh, I didn't add test in there. So hold on, let me remove those two TOML things. And I don't know if it's going to work now. Yeah, there it worked. Okay, so all my tests passed. I only had one test. So the problem that I had is because I added those tests, I added a test dependency on forward diff, but I didn't add test, this thing, right? Like, because I deleted it, it's just using what's in my regular project toml file, which says, oh, you need test. So anyway, minor detail here. If you're going to add specific dependencies, make sure you also add test. All right, so I think that covers some of the basics. I'm now going to get into, let me just check my notes real quick if there's anything else I want to talk about. Yeah, so those are basics for you working with your own projects, whether locally or on your private GitHub or on a public GitHub. But now I want to cover a few things that are slightly more advanced, but are useful for reusability. So if you're not interested in registering packages or doing like automated testing on GitHub and documentation, then you can end, but I'm going to cover those things now. So let me go back here. What else did this thing create? Docs, I'm not actually going to talk about a lot there. Maybe I could do an example one day, but documenter.jl. There's good documentation here. This is what most people use for creating documentation on Julia, and it does a good job in terms of being able to support a lot of things like math, pulling in doc strings from your code. And let me just actually pull up an example. So let me just do, for example, CC Blade. So this got a relatively short set of documentation. So this is generated by Documenter. So for example, you notice I have examples, and these examples are actually run when I generate the documentation. It's going to run this on GitHub and generate these things on the fly. And this is kind of like this is not unit test, but a secondary form, I guess I would say, because it's going to generate these plots on the fly and so on. So I can put examples, figures, and I can group examples. So even though I've broken these up, I can put, by the label I put on these examples, it will say continue these things here, for example, meaning this RTIP is available to it, but maybe I want to start a new example and I'm going to have new variables. So you can do all those kind of things. You can pull from your doc string. So for example, all this stuff I didn't write, well, I did write, but I didn't write it again. I wrote it in my doc string. So for example, here's the doc string. If you're not used to doc strings in other languages, definitely go look that up. This is very good practice for you to write doc strings for your code. So people who are looking at your code can know what these things are, follow the format. And if you follow the format, then you don't have to, then you can just pull them into the documentation and it will kind of recognize it. And so this is good to kind of have the API thing, and you can explain things a little more here. I've got some figures and so on, and then got a theory section. And actually, this is not Julia specific, but I like to follow, there's this, I don't know what this is, a website, a blog or something that suggests these 4 purposes of documentation. And I find this to be a pretty useful way to think about this. I've kind of got these on these different axes, but you could, just to talk about each one, there's kind of the tutorials, the person who wants to come in and just, I need to kind of follow a guide and just see what this thing does. And how to is a little more specific, like there's certain problems you're trying to solve, like this, I'm just trying to learn what this thing does. And here's like very specific guides here. This is like the API reference, and this is more like theory, like what is this thing actually doing? So you'll notice I structured my code that way, or in my documentation, there's an intro. Quick start, that's kind of that tutorial thing, like here, just run through this and you'll get these outputs and you can see what this more or less does. But here's some examples. That's kind of that second part about how-to stuff, like, oh, you want to get derivatives? Oh, you want to run it in a wind turbine mode? Here's how you would do that. And then there's kind of the reference section, like, okay, what are all the things this function does? What are the expected types and so on? And then the explanation part here, I point to a theory. So I have a preprint, or actually not, it's a published paper that goes into exactly what's being done here. So I find that useful. If we look what was generated here, it's going to be the minimum. Again, this has its own dependencies, so it's kind of got its own project. There's the make file, which you'll want to look at here so you can modify it. You're going to put the names of your different pages here, but then the source is going to be in this index file. You're going to use markdown files, and so it's pretty straightforward. But definitely want to do that as you get ready to make this publicly available, your code. Okay, so now let's talk about some other things that are here. Let me get back out of the documentation. A few other things it generated. So let's list everything. By default, LS doesn't list my hidden things, right? Hidden things have a dot appended to them. So I already showed you the get ignore file. Get's nothing exciting. It just did what you would have done if you did a get init. And it set your upstream to be whatever you put as your username. You can easily change that or whatever. But let's just set it up so that when I go to push this, it's already, assuming I created this repository already on GitHub, an empty repository is going to push it into that name. But the interesting things are here under this GitHub one. So let me see what's under GitHub. There's a dependent bots thing, and then there's these workflows. So I've got a few of these things here. So actually, let's edit CI one. And that is, so what is CI? Well, CI is continuous integration. This means that when I push my repository onto GitHub, it is going to automatically run my unit tests. So I just ran them locally, but I want to run those every time I push or more, and also every time someone makes a pull request so that I can see if those tests are passing, right? Before I try to merge someone's pull request or look more closely into it, I want to see at least, did it pass the unit test? I don't want to push or pull in broken code. So there's the only thing, so you don't really need to understand any of this, and there's no real use going through here per se. The only things that you potentially change is right here, and you can configure those on those. These are the defaults, but it's a matrix of what tests do you want to run. So this is saying run it on Ubuntu with 64-bit architecture and with these versions of Julia 1.7, 1.9, and then the nightly version. I typically do something like this. I don't really care if it's going to pass on nightly. That's going to break too much. I put 1, which means the latest version of 1. So right now it'll be 1.9, very soon 1.10. So it'll do, I might do like the latest stable, like 1.6 and then 1, for example. And then I might also add, I can't remember, is it Mac OS or something? You have to go look it up. I usually add those two because those are the two that we use in our lab. But or you can also sometimes add all three. Windows latest, for example, 32 bits, another option here, but I don't really use that, so I don't test on that. So as an example, again, I'll pull up GXBeam as an example here. How is this useful? Well, let me just go to a recent pull request. So here's this pull request, and you can see when that pull request came in, it automatically ran some tests, and it ran it. You can see this has been set up to run it on the latest stable and then the latest Julia. So 1.9 here on Ubuntu and 64, and those all pass, right? And here actually the documentation failed. I was looking at this earlier. It looks like a figure or something's out of place. Not actually a problem with the code, but we got to go fix that. That doesn't tell me that necessarily I should just merge this blindly, but at least gives me these checks that, okay, these code tests are passing. And so if these failed, then that gives me another check here, right? And as I push code here, when those pass, it's going to make this badge green, right? It's going to say, oh, this is passing. Or if it's not, it's going to say failing, and there'll be a red thing here. That was what was shown here in my README. This thing that says build status, that's just this image here. So having these automated tests run, super useful, right? Especially as you've got multiple people working on these codes and you want to make improvements and so on. All right, so what else is here? There is a few other things here. There was a compat helper and a tag bot. So let's talk about compat helper. Shouldn't have to change anything here. But what does that do? Well, what it does is it is going to, well, actually, let me show an example here. Let's go back to my project Toml. Remember how I had to put these compat bounds here? Let's say now statistics bumped up to 1.10. And I kind of want to keep things, reasonably up to date. I don't want to fall super far behind. Like, let's say I say, I never update this, and I put like, say, this went to 2.0, and everybody's on 2.0, and it's been like years, and everyone's on 2.0, and I am saying, no, you got to be on 1 point something. Then it's going to be really hard for people to use my code, especially with other packages that are saying, no, you got to have at least 2.0, and I don't have that. So what does compat helper do? I don't want to be checking all my packages for all their dependencies all the time. All it does is this going to send you a pull request anytime something gets updated. And it's going to say, hey, look, the Simplicity package got changed to 0.3. You should consider changing yours. And in fact, it'll change you the pull request. That's going to say, here, let me automatically change that file for you. Of course, it doesn't happen. You still have to merge it. It's not actually changing. It's saying, look, I haven't tested this. Like, here's just a suggestion that you might consider this. And then in conjunction, if I've got that CI YAML, right, it's going to see if these tests are passing or not. And then I could say, oh yeah, great. Looks like that new version is no problem, right? It's a nice, easy way to keep those compat things up to date. Often when you've got these conflicts, it's because these things kind of get out of date. And so that's a good thing to do. And then what else was here? Oh, tagbot. Tagbot, again, nothing really to change here. So what's tagbot? So eventually, I talked about how, when you could add a package and it just worked and you didn't have to add it by the GitHub URL, which you can do, right? You can add it by URL. But if I can just add it from its name, that means it's in the Julia registry. So if I want to register a package, it's very simple. All you do is you look here at the registrator thing here. You got to install this app here, and then you just follow a couple steps here. You change your project toml to the appropriate version, as we talked about, and this would be a fine version if I was starting out. And then you just add this comment on the commit that you want to register, and I'll show you that. And that's really it. If something's wrong, like you should read this because there's some requirements on what the version can be, and some naming, some kind of naming requirements. And then it will run some tests to make sure this works, and then blah, 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 it'll register it. So it'll be in the general registry. So actually, let me just show you that. Let's pull up CC Blade, for example. So let's say I go to my commit history, and I don't know, looks like I gotta check something here. Probably this one. So I bumped a version here, simple change, and I wanted to register a new version. So notice I made that comment here, and I've got that app already installed. So it goes and says, oh, okay, yeah, I made a pull request, and it tells me once this is merged, then you should tag this. If you know get tags, then you'll know what that means. If not, you don't have to worry too much about it, but tag it and push it. I mentioned there was this tagbot thing, right? Like here's tagbot. If you have tagbot, it's going to do all that for you. So what that does is once it's in the registry, it's going to tag a new version and release it. Here, see in releases. So here it's going to now say, okay, yeah, let's tag it and release it as version 2.5, which you would do manually, but it's just going to do that for you. Just makes life easier. So anytime you need to make a new version, just to Julia registry, whatever that command is, and then tagbot's going to take care of once it's actually officially registered, tag it and release it for me. So that's tagbot. Dependabots. Actually, I haven't used it, but I was just reading about it just barely as I was looking over if there's anything new in that package templates. It does the same thing that Compat Helper does, but for these guys. So as these scripts, ci.yaml, and those things get updated, it'll alert me to a change there. There is also with docs, no, actually, so the doc can also be built online, but that's in my make script here. So I think that's all I really want to cover with that. Again, unit tests are super important and even more powerful if you use this continuous integration, because then these tests are being run automatically and you can see when things are passing and so on. Before we're merging things. And as you get things public, that's really the way you want to work, right? You don't really want to be pushing directly to master. You want to be working off a branch, make a pull request, make sure everything's good before you push. You don't want to have push broken code. And ideally have someone review it and so on. So I think that covers probably everything I want to talk about with packages. So that'll be it for today.